Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Chronosphere. My name is Cody J. Brown. I'm the host of Techstrong Learning. We've got an exciting webinar for you today. First, I have a couple of housekeeping notes to cover. First, today's session is being recorded. So if you miss any of our session or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we do want you to send those in using the Q&A tab, which can be found on the right side of your screen. This is also where you're going to find the chat tab, and that's where we want you to speak with one another, speak with us. Just let us know your thoughts throughout today's webinar. Maybe just let us know where you're from. We do have a couple of polls we'll be launching throughout today's program, so be sure to keep an eye out for those as we do want your participation. And I'll also point you in the direction of our handouts tab. So if you look over there, you'll see about 7 resources that will help aid in today's presentation. So feel free to download those at your own leisure. And of course, before we close, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around until the very end. So our topic today is 4 signs it's time to level up Prometheus. And I'd like to introduce today's speakers from Chronosphere. Gibbs Cullen is a product solutions manager at Chronosphere, where she makes it possible for the community to understand key concepts behind cloud-native metrics, monitoring and observability solutions, including Prometheus. Prior to Chronosphere, she was a product manager at AWS and Amazon's Alexa team. So Peter Simkins is an engineer at Chronosphere who entered the observability space with 10 years of experience at Disney, leveraging many technology solutions across 50 unique business units. After several years in the APM monitoring space, he's excited to work with some of Chronosphere's largest enterprise organizations in the world to solve observability through modern open source-based solutions. Gibbs and Peter, thank you so much for being here with me. I'm going to let you take it from here.
Awesome. Yeah, thank you so much, Cody. We're very excited to be here and to speak to everyone about the 4 signs it's time to level up Prometheus. So just going to run through the agenda real quick. So we're going to start out giving a very high-level overview of Prometheus for those who might not be as familiar. Then we'll go into each of the 4 signs that kind of center around scale, reliability, efficiency, and finally cost, where Peter and I will kind of go back and forth going through what this looks like in practice, followed by some real life examples of these signs in practice. And then, of course, there'll be plenty of time at the end for Q&A. So make sure to put those questions in the Q&A chat, as Cody mentioned, and we'll hopefully get to as many as possible. Okay, so I think we're going to start out with a quick poll. So give everyone a couple seconds to do that. Okay. And I don't know if we'll be able to see the results right away or not, but oh, okay. Here we go. Okay. Oh, wow. So we have quite a good mix here. A lot of people new to the space, so that's awesome. Excited for you to learn more. And then we have some experienced users as well. So I think a good mix. Great. So I think we can move on to the next slide. Okay, so quick overview of Prometheus. So Prometheus is essentially an open source metrics monitoring solution. It's part of the CNCF, which is the Cloud Native Computing Foundation, and it is their recommended metrics monitoring tool. And so as a result, its exposition format has become widely accepted across the industry and the space, along with its query language, which it's called Prometheus Query Language, or PromQL for short. Some of the reasons why it's become so popular and widely adopted is because it's first off really easy to get started. So basically, you just have to spin up a single binary to do any sort of ingestion, storage, and query. And then same thing on the alerting side. So really easy to get started out of the box. It also has a variety of ways to discover Prometheus across various platforms, including some of the really popular ones like Kubernetes. And finally, there is a very large ecosystem of exporters, which are essentially just existing software integrations. And most of the major software integrations or projects, especially in the open source ones, will have these exporters or integrations for Prometheus. So I encourage you to go look at their documentation if you're interested in learning more about these. There's a full list of what these exporters look like on there. So, and as I mentioned, it's kind of the recommended monitoring tool by the CNCF. But you can see here, this is a graph from the CNCF survey that was done back in December 2021. And you can see even across all of observability tooling, it's the most popular project with 86% of the participants kind of using Prometheus. And on top of that, Prometheus has continued to rise in use in production with 63 or 65% of people using Prometheus. They're using it in production, which is about a 43% increase year over year. So really quickly growing in adoption, which is exciting. Okay, so on to our second poll question. And these are going to be tied to the 4 signs that we're going to talk about. So I'd love just to see where people land on this one.
Just want to add, don't be scared. From the first poll, sounds like people are just getting into Prometheus. So it's okay. We'll go through all of the good.
Yes. Oh, wow. Okay. Got a mix here. So seems like for most people, the biggest pain needing to retain longer term data, followed by losing monitoring data due to volume constraints. And then the third one being increasing costs. So hopefully we'll give you some good insights into how to hopefully address some of these pains in the following slides. But this is really interesting to see. So, okay. All right, so we're going to get into the first sign. So sign number 1, your engineers are struggling to locate monitoring data quickly and efficiently. Okay, another poll question. Okay.
Interesting.
Yeah. Very interesting for sure. So yeah, so how much time do your engineers spend managing your team's Prometheus and or monitoring operations? So majority saying not too much time, maybe once or twice a week. They're looking at it and managing it, followed by more and more as we scale. So having them spend more time as the operation gets bigger. And then with 9% saying all day, every day. So it's like a full-time job for these engineers. So, okay, that is interesting to see. So let's get into what this would look like in practice. So if you were running Prometheus, kind of how you would experience this pain point or what this could look like. So in this example, we have pretty basic setup here. You'll have your Prometheus instance, which uses a scraper pool based approach. So it'd be scraping metrics from your services here. But let's say, all of a sudden you realize that service A is starting to produce a lot more metrics. And in an effort to prevent your Prometheus instance from going down or being overwhelmed, you want to spin up a second instance just for service A to kind of appropriately manage that load. So you spin up the second instance. And now you have 2 instances or data sources collecting metrics from your services. And typically when you are thinking about metrics monitoring, especially at like a cloud native scale, you kind of want to figure out a way to start with like a high level overview of what's happening and kind of have that single point of view or the single point of query before you then dive into specific instances or specific services. And so the goal here would be to kind of get to a central point of query across both of your data sources and across all of your services. So the way that you would do this is you'd spin up a third instance of Prometheus through this process called federation, which is very similar to kind of sharding. So you basically will shard your existing instances here into this third federated node, which would basically have a subset of metrics across your instances and across all of your services, providing kind of a way to get that overview of what's happening across everything. And then from there, you can point your instance of Grafana, for example, if you want to do any dashboarding or querying to that. And then same on the alert side with the alert manager. However, since it is going to be a subset of metrics, you want to make sure you leave these lines of communication to the existing data sources as well, in case there are use cases where you need to query or look at or learn on specific metrics that aren't a part of this federated or sharded node. And that's a very common way to get to the single point of query. And it can work just fine at smaller scales. However, where you might start seeing or feeling some of the pain points of this setup is when you do scale it to a much larger sized operation. So taking this diagram, for example, let's say these are 2 different regions here. And in order to accommodate the level of scale that all of your services are producing, you need to add more and more instances of Prometheus. And in order to get to that single point of query, which is kind of the end goal here to kind of start your metrics monitoring process to see what's going on across your entire stack and your entire operation, you can see that there's multiple layers of federation here. So, and within each layer of federation, it's going to be a subset of a subset until you get to this single node here at the bottom. And you can imagine that this could be really time intensive for your engineering teams or team to kind of manage and keep up to date, because each time you add a new instance, you're going to have to have a kind of update your mental map, a mental model of kind of where the metrics are living and inside which instances are the metrics. And so in order to kind of keep this up to date, it requires a lot of overhead from the engineering side of things. And if you expect this to kind of keep scaling, you can imagine it's going to require more and more time. And your engineer is going to have to spend more time kind of managing this Prometheus operation versus spending their time on more valuable work for the company. So if this is something that you can relate to, then you may be starting to kind of outgrow your Prometheus operation, and you may need to start thinking of ways to kind of level it up. So I'm going to now turn it over to Peter, and he's going to give an example of a real life scenario where a customer was feeling this and kind of some things that they did to resolve these pains.
Yeah, thank you, Gibbs. This is a great example. First of all, I love Prometheus. The ability to be flexible in your monitoring is infinite. So this example that Gibbs has is very common. See this with a lot of customers. And some of the areas that they can get immediate relief or get some flexibility in is by introducing recording rules. This is something that's unique to Prometheus, meaning you can take a specific query, you take the result of that query, and that's what you actually store. So think of it as a way to pre-process everything as you ingest your metrics. And another thing that people often overlook is something as simple as the scrape interval. So Prometheus has flexibility around the urgency or the timing of when you need your metrics. So fantastic, I think, point to stay in is like a 15-second scrape interval. Usually users don't notice any sort of lag. It's very, very easy in terms of I guess adjusting it to match your needs. And I have customers that will do a 30-second, 60-second, and as you can guess, it greatly reduces your metrics. So as you scale out like this, think of just easy ways that you can, I guess, under the hood, make it efficient, so you can scale as time permits. Anyways, I'm going to go to the next slide and just briefly talk about one of the amazing customers that I've worked with. Tecton had multiple customers, and they would spin up a Prometheus instance for each customer to get critical metrics, and it definitely worked as they grew, but they essentially grew too fast. So first thing that we did is work with them on recording rules, as well as adjusting the scrape interval to match their needs. Anyways, lots of customer stories. Please add questions as we go. I can't wait to hear what people have run into. And by the poll, it sounds like everybody's new to Prometheus. Don't be scared off. It's an amazing technology, and probably the best that I've worked with in 10 plus years, we'll say.
Awesome. Thanks, Peter. Okay, so moving on to sign number 2. So this is going to be around, so if you're losing monitoring data that's needed to keep your mission critical services running reliably. So starting off with a quick poll. I think we only have 2 more poll questions after this, so don't worry, you're almost done. Oh, wow. Okay, so we got a little bit of everything on this one. Cool to see. Okay, so reliability and availability being the top concern for people in their business. Okay, that's great. So I think that's actually going to be the topic of this next section. So that is very fitting. If you want to move to the next slide. Okay. Okay. So, so basically what this might look like, or kind of how you might start experiencing this sign in your Prometheus operation is, let's say you have your service A here up and running, and you have an instance of Prometheus tied to service A to kind of do any metrics monitoring on that service. But let's say all of a sudden this instance goes down for whatever reason. So not only will you temporarily lose your ability to real-time monitor service A while this instance is down, but you're also going to lose any sort of historic metrics that have been already scraped and stored by the instance for service A. So pretty significant point of failure with this sort of setup. So what most people will do in this situation is they'll try to create a highly available model. So meaning that you have 2 or more kind of service or instances tied to a service. So in this particular example, we have 2 Prometheus instances tied to service A. And so, if one instance did go down, you still have one instance up and running to keep your monitoring live and in real time. So this is kind of a workaround. However, kind of going back to what we talked about a little bit in the first sign is you really want to have a way to query and view your data across view data across your instances and services in a single place, and kind of having that single point of query. And so kind of with this setup, the way that you would do this is you would basically implement a load balancer, and that would kind of distribute requests across your instances for your service. So, if you have an instance of Grafana, for example, to do your querying and dashboarding, any sort of request will get sent through the load balancer. And then that way you can kind of query across both of your instances from a single place. And then you can kind of get a sense and overview of what's going on with your service. So The problem with this, though, is, and when you might start to see some of these, the pain points, is if you are needing to do a rolling restart of your instances for whatever reason. It's a really common thing to do. So if you're doing any sort of maintenance or upgrades on your instances, they're going to have to be, they're going to have to restart. And when they're restarting, they're going to be down temporarily. And when they're down, obviously you're going to have a gap in your graphs. So you can kind of see here in this diagram, each of these graphs here is supposed to represent one of the instances on the previous slide, but you can see that there's a gap in each graph, and that's when the instance was doing its rolling restart and when it was down. And these restarts don't necessarily happen simultaneously, and so basically you can have these gaps at different periods of time. And with the load balancer there, you're basically your request is going to get sent to one instance or the other. And so you'll basically get one result or the other, and meaning you'll get one gap in the graph versus a different gap in the graph. And then that's going to lead to very kind of unreliable and inconsistent results, especially as you scale up, because you're going to have various gaps in your graphs that don't really match up. And you don't really have that single source of truth. And with kind of open source and like out of the box Prometheus, there's no real way to merge these data sets to kind of create that single source of truth. So if this is something that you feel like you've started running into, definitely might be a sign that it's time to level up and think about ways to kind of enhance your existing Prometheus or monitoring solution. And I'm going to turn over to Peter to give some more context from a customer of ours giving that experienced something similar to this and kind of how we got around it and some things you could implement.
Yeah, thanks, Gibbs. Based on the poll, we picked the right topic to talk about since reliability was right up there on top of the list.
Yeah.
So yeah, as Gibbs went through, I've seen customers implement simple things like load balancers. I think that getting remote storage and distributing based on different cloud regions, cloud providers, anything to increase your reliability are just some easy wins, right? So a lot of customers will have one monolithic or huge instance of Prometheus. This isn't bad as long as you have a good failover or you're not losing any of the data that you store. So highly recommend not running out of storage. And come on, storage is pretty cheap now. You've got S3, a bunch of simple storage out there. So yeah, just definitely go for, as Gibbs highlighted in her architectural diagram, put a load balancer in front of it, have different instances that are in different cloud regions and just load balance across the two and fill in any of those gaps. So definitely don't want to be in a position where you have a critical issue and you don't have that data. So super important. Genius Sports, great example, just massive data growth. They basically push the volume to the limit, and they got around a lot of their concerns just by using different regions. So a great example of cloud success. Anyways, keep the questions coming, by the way, too. We'll definitely hit those at the end.
Yes, definitely. Okay, so moving on to sign number 3, which will be teams are needing to retain more data for longer periods of time. And of course, to start out, we're going to have another poll. All right. Exciting to see people from all over the world here, like Los Angeles, Bordeaux, Egypt, California, Mexico.
Isn't that amazing?
It's pretty crazy.
And I have no favorites. I have not been to Egypt, but definitely want to get there.
Yes, me too. Wow. Okay. Another good mix of responses here. So how do you currently store or manage your longer term data? So we have some people doing a homegrown or proprietary solution. Others don't have any sort of long-term storage solution. And then we have also a mix of open source, so Prometheus or remote storage solutions like Thanos and Cortex, and which is listed twice actually, and then the fully managed SaaS or fully managed on-prem. So that's pretty good. That's a pretty good mix there. Very cool. So kind of get into so this is going to be more around efficiency in Prometheus. And basically, so just to give some context, Prometheus, with its single binary setup and approach and being able to being efficiently able to store metrics inside the instances themselves, it's really good and optimized for storing shorter term data and metrics. However, where you start running into problems is if you are wanting to store your metrics for these longer periods of time or longer retention periods. So, and that really comes from Prometheus not having any built-in downsampling capabilities. So just wanted to kind of show what that can look like from an efficiency perspective. If you look at these examples on the left side of the slide here with these numbers. So let's say you have one instance of Prometheus and you are storing your metrics for 6 months at a 30-second resolution. If you were able to downsample those metrics to a 1 hour resolution, you can see the efficiency gains are quite large there. And that's just with one instance. So if you were kind of running 100 instances of Prometheus, you can see the efficiency gains are much, much larger. And the discrepancy between the two numbers there is pretty significant. So not having that capability can be pretty detrimental to your solution, or pretty costly, I guess, as well. If you don't have that kind of capability built in and you are wanting to store metrics for longer periods of time. There is a way to get around it with your open source and out of the box Prometheus. So basically, if you look at this diagram on this slide, you would have your service A here, and you would basically scrape metrics in service A into that first instance and store them at the 30-second resolution. And then from there, you would kind of set up or spin up a second instance through the federation process, which we touched on earlier. So kind of taking a subset of those metrics from the original instance, and then you would store that subset of metrics at the higher resolution, so at that 1 hour resolution. But again, you run into the problem of having two data sources that, like if you have Grafana for dashboarding and querying, you would have two data sources to flip between and look across to see what's going on at each resolution or in each retention period. So so you're not going to have that single point of view and that single point of query to look at when you have this setup. So and obviously, if you keep doing this for more services and more retention periods, you're going to have more and more data sources to kind of flip between and like manage. And you're not going to have that single point of view, which can obviously not very efficient in terms of time being spent by your engineering teams. And also, it's going to be more capacity and kind of costly on that end as well. So I think, Peter, you're going to touch on. Okay, well, actually, so we're kind of wrapping up an example. Peter, do you have anything to say actually to this?
Yeah, so remember earlier when we were talking about the scrape interval, there was a great question on what's the detriment of reducing your scrape interval. And this is a great example as customers move into containerized applications. As Gibbs points out, one instance at 30 seconds, you're looking at 8,000 kilobytes a second. And then, of course, as you move to 100 instances or 100 containers, it never stays at 100. You're talking about thousands of containers. So you can see this exponentially grows. So to kind of hammer home that interval, scrape interval, as you get more and more aggressive, you can see your metrics are going to explode. But if the business can tolerate it, reduce the scrape interval, right? So instead of 30 seconds, go to 60 seconds, right? Like find ways to, I guess, help you in that massive growth. But yeah, this gets out of hand really, really quickly. The more metric tags that you introduce, as well as the basically the containers that you have to monitor. So yeah, love this example, Gibbs. Thank you.
Great. Okay, so I think we're going to move on to our final sign number 4. So your monitoring costs are out of control, and so you've stopped collecting some of your metric data. So we don't really, okay, last poll question.
And Gibbs, we should point out that by solution, that's like, yeah, like logs and traces and metrics and all the different solutions, right?
Yeah. So yeah, if you have separate solutions for each of those different
I
types.
bet you've talked to a lot of people that use quite a bit. So at least I have. And super interested to see if there's a lot of homegrown. Okay, right on.
Okay, so majority are using 1 to 3 solutions, and then we have some using 3 to 5 and 5 or more, which is quite a lot. It's a lot of data to manage across solutions. So great, thanks everyone for answering these. I think that was the last poll question too. So, but yeah, Peter, I think you're going to be taking the next one, I believe.
Yeah, so this is a really common pattern. And by the way, all the questions we will get to at the end, just so everybody knows. I can't wait to talk about that. But as we see, basically customers going from on-prem data centers, the growth of metrics was pretty stagnant. And then as you move to the cloud, there was a lot of lift and shift. You just move your applications, your workloads directly to cloud. Not much improvement, but now the evolution, if you will, is Kubernetes. It's containerized applications, and metrics that come natively with Prometheus are fantastic, very, very detailed, but it explodes, right? The number that we see is around 71% of companies are concerned with just the massive growth. So when I talk to a lot of customers, this is usually top of mind, right? Is the business may be growing at 20%, 30% year over year, but as they shift to more resiliency with containerized applications, they see the monitoring or observability footprint exploding. And this is like, front and center. Everybody's like, how can I reduce the cost, but I don't want to lose anything? And Gibbs, you've probably seen this. I want to keep every metric. I want to keep it forever. And then you have to have this hard conversation of, you can't keep everything. Can't keep it forever, right? There's no silver bullet. And it puts you in a weird position in terms of vendors will come in and say, we'll get you everything that you need by sampling. And that's just a really common pattern. So yeah, as you grow, just factor in that you're going to have a lot of tech behind it, and you don't want to necessarily miss anything. So I don't think the answer is to do ratio-based monitoring or scale down. You just have to plan and account for this massive growth that you're going to have without breaking the bank, so to speak, with the business and how they're growing. Gibbs, do you have anything to add on that?
Yeah, and I think, obviously we don't have a kind of a example here of like how could look like with your Prometheus operation, like the previous signs. However, this does kind of like encompass all the previous signs in a sense. So it's kind of a good one to end on in terms of the impact that all these previous signs they would all eventually lead to this outcome that Peter talked about. So I think we do have one last kind of case study to walk through, kind of going through this sign as well as the previous one a bit with one of the customers we've had.
Yeah, this is one of my favorite customers, Abnormal Security. They've had record 80% growth year over year. just booming. And it speaks to that growth curve that we just saw. And what was interesting about abnormal is that they used one large EC2 instance of Prometheus, and that's not wrong, right? They were able to scale it very, very well, but at the same time, they were really suffering from being able to go back for long periods of time. And this is a great example of just tuning the scrape interval, using remote storage, and working with them, moving some of their workloads to ECS, where it gets a little more elastic as well. So just great example of being able to scale with massive growth, but they had to plan for it. And that would be my takeaway, or if I could leave everybody with something, is just plan on growth, because you never know when you're going to have 80% massive growth. And I hope you all do 80% or more. So yeah, just a great example of good planning. And they went centralized, or one big instance, versus distributed, and it worked really well for them. So yeah, just wanted to give that feedback.
Yeah, no, and on top of that, I mean, if I know we have some people that respond to the poll saying that they do use remote storage solutions, and this can be for at least on the kind of data retention side. If you want to stick with open source, like some of these remote storage solutions can be a good way to get around some of these pain points and kind of make your Prometheus operation or your monitoring operation a little bit more manageable and efficient.
That's a really good point. And another thing to add is they had several tools. Getting back to your poll question, I guess the goal should be use one sort of backend or time series database, if you will, for things like logs, tracing, metrics, if possible, because every time you have from the polls, I think it was like 1 to 3, it gets expensive, both time-wise as well as financially, to run all the different solutions. So when possible, if you can consolidate, it's going to come out much, much better.
Yeah, that's definitely a great point. Okay, so before kind of wrapping things up, just wanted to give a quick overview about Chronosphere, where Peter and I both work. So just a quick overview of the product at Chronosphere. So essentially, we have a platform that can accept both metrics and distributed trace data to help either whether you're a developer or SRE or kind of a part of a central observability team, help kind of perform these various use cases here to remediate your problems as fast as possible. And one thing that I think is unique about our approach to observability is we kind of think about everything in observability from a more outcomes focused approach versus a more traditional approach that you may have heard about observability around the 3 pillars. So 3 pillars being logs, metrics, and traces. And that's very much, you'll probably hear that a lot when kind of hearing about or reading about observability. But we kind of think about it in a slightly different way. So we kind of have here the 3 phases of observability. So know, triage, and understand. And basically, what all these 3 phases do is they all kind of lead to a way to help our customers remediate the problem as quickly as possible. So it's kind of, it doesn't really matter if you have all 3 pillars or all 3 types of telemetry data, as long as you have the appropriate amount of data and enough information, along with the tools and capabilities needed to do this remediation and do this triage, and then also be able to kind of go back and post-mortem and understand any problems you may have quickly and efficiently so that you can fix these problems and prevent them from happening again in the future. So that's just a different way about thinking of observability, and kind of would love to hear if anyone has any thoughts around that as well. And yeah, so just to kind of recap everything that we've gone through and talked about during today's webinar. So just for some next steps, we've linked a bunch of things here. So to the various case studies that Peter touched on during the webinar, we also have some free resources to kind of supplement the points that we covered today. And they should also be all linked in the handouts tab within the portal. So one that is really great is the 4 Signs It's Time to Level Up Prometheus. It's a quick sheet really summarizing everything we talked about today, along with the Prometheus native monitoring SaaS solutions, like a buyer's guide, which has more questions to kind of help you consider whether or not it is time for you to kind of level up your Prometheus. And of course, if you want to learn more or kind of connect with us after this webinar, feel free to schedule a conversation with us or a demo. We would love to chat with you about anything covered today or anything kind of related to Chronosphere and kind of cloud native observability in general. So I think with that, we will kind of turn it over to Q&A and try to answer all the questions that have been coming in throughout the webinar.
Yeah, we've got questions.
We do have some questions.
Should we jump in? And so I've answered a few of them, but let's just answer them live if we can. So what makes Prometheus different than other time series database?
Okay, so it looks like do you want to talk to this, since I see you kind of answered it?
Sure. Yeah, that's cool. That's cool. And just correct me or jump in at any time. So, Prometheus has a great time series database, but I see a lot of customers saying that it doesn't necessarily scale. And it really comes down to a function of, do you want to consolidate everything into one data store? Do you want a distributed approach? There's nothing wrong. Like Gibbs, when you started out, you had multiple Prometheus instances, and then you would federate it or shard basically into a logical set. There's nothing wrong with that. That's fantastic. But just want to point out, I see a lot of customers looking at things like M3DB, Thanos, Cortex, etc., to basically centralize all of your metrics in one place. Gibbs, is that what you see? Like, I think there is a saturation point.
Yeah, I think, I mean, solutions like those, like M3DB, Thanos, Cortex, are definitely great to send your Prometheus metrics to have more central place for your metrics monitoring, and also be able to accommodate larger scale and longer retention periods as well. So I think it all kind of depends on your use case. Like Prometheus, like I mentioned in the webinar, it can be really great for use cases that are wanting to store data at shorter periods of time, and that might not be at the massive amounts of scale that you see in these cloud native use cases. So it really can vary based on your use case.
Yeah, that's exactly what I found too, or what I've heard. I'm just going to jump into the next one. What are the detriments to a smaller scrape interval? And I struggled with this one a little bit at first, but there really is no detriment, in my opinion, to being very aggressive. It's kind of what you can afford, right? And what's needed. I just think it's wasteful if you set like a 1 second scrape interval. It's like diminishing returns, right? Like, do you need up to the second? Do you need sub-second? I get it if the business requires it. Go for it. Gibbs, what are your thoughts?
Yeah, I mean, again, it's very case by case, but I think there's not like necessarily any detriment, but it does come back to like, how much can you afford to, and how often can you afford for your scrapes to run and your queries to run? Because like the more frequent these or the more often the scrape interval and the shorter the scrape interval, the more you're going to be querying, and so there's obviously some cost to that. So it's kind of, you have to kind of think about what works best for your constraints and for your use case.
Yeah, I agree. Okay, we're just going to keep them fast and furious before we run out of time. Should I just read these out, Gibbs, and then we can tag team them?
Yeah, let's,
Okay, so I have a question. At what level of scale will I start experiencing these pain points? What should I look for? So, I mean, this is a great question as well, and I haven't had a chance to answer it quite yet, but let's answer it live in person.
Okay.
So, there's no hard or fast rule. I think if you distribute multiple Prometheus instances and federate it, as Gibbs was talking about, I think once you hit, I don't know, 10 or 15 different Prometheus instances, and you've federated it as much as you can, you might be hitting the limitations, right? And I guess if you have one massive Prometheus instance, you're going to run into problems eventually around speed of query, probably, or being able to retain that data and going back large amounts of time, and getting back to the remote storage as well. If you just have a high volume of metrics, it's going to get oversaturated. So it's up to you. It's the bottom line. Gibbs, what do you think?
Yeah, and I think I'll add to that. And like, again, all these things are very case by case, but I think kind of going back to some of the pain points that we discussed in the webinar, like if you're starting to see that your engineering team is spending more and more time managing your Prometheus stack, or if you're having to hire more people, more full-time engineers to kind of run your monitoring, then you should probably start thinking whether or not like that is really that the ROI behind that. And then that's usually a good indication that maybe it is time to level up your operation and think about other solutions to kind of help manage your operation at a more at a larger scale and at a more efficient and in a more efficient way as well. That doesn't really require you to keep adding engineers and overhead to your team. So little things just to think about. Yeah.
That's awesome. I agree. Let's see. Sorry, just going through. Wow, here's a good one. This will take a few minutes to get through. So right now we're using Datadog Opportunity to actively monitor our application and alert on threshold event failures. Oops, hold on. The thing just moved.
Oh, sorry, I think I accidentally published it. So, I
wanted everyone to see. Thank you.
Yeah.
Awesome. Thank you. I forgot to publish it. So we're using Datadog Opportunity, actively monitor application, and alert on threshold event failures. If we move to a K8-based system and want to use Prometheus, will we still need to use Datadog to visualize alert? Or does Prometheus provide a visualization component? Are there other better options? Gibbs, can I take first crack? I'm actually really passionate about this. So I've used Datadog a lot. I like Datadog, not trying to bash on anybody, but there's a lot of proprietary metric monitoring and observability solutions on the market. Datadog even offers different ways to transform their like DogStatsD metrics into Prometheus, but they're not a native Prometheus ingester. So if I were moving to a K8s based workload or stack where you already have Prometheus, you have a couple of options. You can install the Datadog agent and all of the integrations. You could have Datadog ingest your Prometheus metrics as well. They support that, but you don't have to use Datadog to visualize an alert. So on the open source side, and maybe Gibbs, you can go into a little bit of Prometheus Alert Manager. It's a full-featured, more than complementary to what Datadog would have to offer. And of course, you can use visualization tools like Grafana, which are kind of the, visualization standard on the open source side. So don't feel like you're tied in to Datadog if you want to move over to Prometheus, which is most likely already there. So I'll pause there. Gibbs, come over the top.
Yeah, and I think just to add, so I think I failed to mention at the beginning, but Prometheus does have a way to visualize and graph metrics inside, like out of the box. However, it's not usually recommended for production purposes. It's more like meant for experimental purposes. So to that point, like to Peter's point, like if you did, you definitely don't have to use Datadog just like for any visualization, but so if you wanted to stick with open source, Grafana dashboarding is a very popular solution. But Prometheus does have that capability, but not really meant for production purposes. So that was just one. That was what came to mind for me. Anything else to add to this, Peter?
Yeah, I mean, and I'll definitely answer in text with what you said there, but just don't feel locked in, right? You're not losing anything, but you gain so much more when you can start leveraging the metrics that are already there. I'll leave it at that. But yeah, Datadog has great visualization and alerting, but so does the open source community as well. And you don't necessarily have to pay for things when it's open source. So it may help your organization if one of your goals is cost savings.
Yeah, and Chronosphere also has capabilities for that as well.
Thank you. We should point that out.
I did have to say that. Okay, so I think, do we have time for a couple more? Let's see.
I'll answer this one in text if you want to pick up the next one. There are a few more. I wish we had a lot more time.
Yeah, I think we answered that one already, I believe. And then, okay. So, okay, just publish this next one. This might be actually a better one for you though, Peter, because I know you've had some things around this. So question is, can we calculate the size of data or storage so we can determine the storage needed?
Oh, yes, this is a good one.
Yeah.
Yeah, so this is if you're using something like the previous question, they're using Datadog today. I usually work with customers who are moving to all Prometheus just by looking at the total throughput, and we can make some estimations. And then if you're already using Prometheus, we can very easily run a couple of simple queries just to see the volume of metrics, but also the size of metrics, and just get a good understanding of what large is. So if you have 4 million active time series a second, and you're running into, I guess, query performance limitations, it may be time to say, okay, we've turned the corner. We need to look at other options. Another area that I see customers experience pain is around the duration that they're saving all the metrics. So if the business requires, I don't know, SREs need like 2 days to troubleshoot, but the business requires year over year, I need to be able to look back 2 years and see what happened every Black Friday or every major event. This is another area, as Gibbs and I talked about, you can use remote storage to expand that out. But if the business requires that long-term retention and you can't provide it, it may be time to turn the corner and look at something else. So no hard or fast rules.
Yeah, and in this process, it's also we have seen a lot of users. It's a lot of like trial and error as well. Like there's not necessarily like a hard and fast rule on this. So I think sometimes you just kind of have to try different things and see what works. And as we've seen that happen a lot as well.
Absolutely.
Okay, I think we might have time for one more question. See what we have left in here. Okay, so we can publish that last one. Let's see. So I'm reaching my limits with Prometheus. What are my options? What are some solutions you recommend? Yeah, so I think we've covered this a bit already, but I mean, there's basically at a high level, there's like two approaches to this. So you can kind of decide to stick with open source and take a more open source approach, or if you wanted to kind of go with the more hosted, like a hosted solution or a managed solution, that's the other kind of option. Of course, there's always like a way to build something in-house and have a more proprietary solution. But if you didn't want to dedicate those resources, those are kind of the two avenues to go down. And we've mentioned a couple of these solutions already, but on the open source side, ways to kind of expand your Prometheus operation would be through solutions like M3, Cortex, Thanos, Victoria Metrics. And then on the kind of more hosted or managed side, solutions like Chronosphere. There's also, someone mentioned they're using Datadog. There's, many other hosted solutions that you can kind of look into that can help alleviate some of these pain points you might be experiencing. So I don't know, Peter, do you have any final?
Yeah, this is the age-old question, build versus buy. So definitely you can, run something yourself. You can build something yourself. It's really, in my experience, at least at Disney, it came down to I need a predictable, cost model and scale model. So, over time, how do I turn this into an operational expense? And it's very predictable. So I know that I can collect all the metrics that I want, that I need, and report back to the business. And if you build it, you always have to worry about the maintenance and support. Versus if you go to a SaaS hosted solution, that company has to worry about the maintenance and support. So there's pros and cons for both. But of course, I'm a little jaded. I prefer the SaaS. Let somebody else worry about it, and I can go complain to somebody if something isn't working, versus if I'm building it myself.
Right, because most of these solutions are going to be purpose built for these problems. So something like Chronosphere, built from the ground up, it's cloud native, purpose built to handle monitoring and observability at the levels of scale that you need. So, all right. I think Cody popped back up. I think we are time's up.
Well, Gibbs and Peter, thank you so much for going through everything today. I do want to give you guys one more opportunity. If there was anything you did want to leave our audience with before we close, or any parting words, I do want to give you that opportunity as well. So,
yeah, I mean, just as a reminder, if you're any of those links that we covered during the presentation or the resources that we mentioned, make sure to check out the handouts tab for that. But otherwise, I think we covered everything, and this was really great. So thanks everyone for your questions and participation in the polls. I think Peter and I both really enjoyed speaking with everyone.
It was a pleasure. I can't believe everybody was from all over the world. Much appreciated.
Very cool.
Well, again, Gibbs, Peter, thank you so much for joining us today. To our audience, I'd like to remind everyone that this session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So we do have those 4 $25 Amazon gift cards to give out. Our first winner is Kuong D. Our second winner is Ria B. Our third winner is Wellington B. And our fourth and final winner is Cosmin S. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim your gift card. But if you don't happen to see that email, please check your spam folder. I would like to thank Chronosphere for sponsoring today's webinar. And I would also like to thank our audience. We really appreciate you being here with us for the entirety of today's presentation. We ask for one extra moment of your time to fill out a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong Learning webinar or workshop. Everyone have a great rest of your day. And Gibbs, Peter, thank you again so much.
Thanks all.
Thanks.